Hello friends, welcome to SR Physics Academy. Today we are going to discuss about Introduction to Matrices. What is matrix? A matrix is a rectangular array of numbers arranged in rows and columns. Matrices are commonly written in a box brackets. The horizontal and vertical lines of entries in a matrix are called rows and columns. There are few basic things we need to know about every matrices. What are the elements in the matrix? What are the order of the matrix? And what are the third one is what is the position of an element? Just these things: elements, order and position of an element. First is we'll discuss about what is the element of the matrix. For example, this matrix has how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8. So total 8 elements are there. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here total 12 elements of a matrix. So elements of the matrix don't have to be the numbers. There could also be the letters. That means A to Z. Okay, any letters we can use or random characters. Next is here the order of the matrix. Here we can say here how many rows are there? 2 rows are there and 4 columns. So we can say that what is the order? 2 by 4 or 2 into 4. Don't forget the number of rows first, then the number of columns next. Here next is the position of an element. So in this matrix, first we will take this element, this matrix. So in this matrix what will be the 1, 1. So okay, 1, 1th element. Here what is the 1, 1th element is here? First row, okay, first row, first column. So what is the element here? 1. Okay. Next is 1, 2th element. That means first row and second column. So what is the number here? 1. Okay, first row, second column. We can say that number is 2. So this is it will be so on. So last one we can say that here is second row and 4th column. So what is the numbers or what is the elements here? 5. So here we can say the position of an element of this one is 5. So these all the elements. Okay, 3, 15, 7, 9, 8, 9, 33, 2, 6, 17, 1, 0. These all we called as here the element of these are the elements. Here, there are many more applications of matrices in various fields such as banking, mining, geometry, probability theory. These are all the things we can applicable to matrix. Next, we will discuss one by one. What is a row matrix? A matrix having a single row. So here in mathematics, a row matrix is a type of matrix that has single row. Okay, here it is a single row, but the number of columns could be more than 1. For example, here first example A equal to, so we have to remember that, yeah, there it is. The matrix are named using capital letters only. Okay. So here A equal to, here written the matrix 8. Okay. So what is the meaning of this one? A row matrix of the order. What is the order here? First row, first column, is it? So it is a one element is here. The element name is here. The number is 8. So here, since here there is only one element of the matrix, so here only one element in the matrix, that is the order in one row, one column. So therefore, the determinant of the matrix A is what is called 8. So let us discuss another one more example. A equal to, here we can say 1 and 2. So here the row matrix of the order 1 by 2. Here there are two elements. What are the two elements? 1 and 2. So there are two elements arranged in a single row. Okay. And how many columns are here? Two columns in the matrix. So hence it is an example of a row matrix. So this is we called as row matrix. So one more we can take it here. A row matrix of the order of 1 by 3. Say what are the elements? 1, 3, 7. So here there are three elements in the matrix. What are the three elements are here? 1, 3, 7. Arranged in a, how this is a, see, the row matrix means the arrangement is important. So here the arranged in a single row. Okay, that single row, and how many columns are here? 3 columns will come. So hope you understood. Now let's take what is column matrix. Here a matrix having a single column. Okay. So the single column is here, okay, 3 by 1. For example, here I am giving an example of a column matrix of the order 1 by 1. So here A equal to matrix A. Here there are only one element within the matrix arranged in one row and one column. So here we can say the determinant of this matrix is, what is the value here? The determinant is 3. So since it is also a square matrix. Okay. Next another example. Column matrix of the order 2 by 1. So here there are two elements are there arranged within the matrix in 2 rows. Okay. Here 2 rows and only one columns. Next we will take another one more example, that is the order is 3 into 1. So here how many elements are here? 3 elements. Okay. So 3 elements arranged within a matrix. Okay. That is the square it will come box. So in his how many rows are here? 3 rows. 3 rows are there. 1. Okay. 3 rows. And how many columns? Only 1 columns. Next is zero matrix or null matrix. That it is a heading only we understood. It is an all the elements are 0. Okay. So it is lookwise how that is the square matrix and 2 by 2 matrix. 2 rows and 2 columns. So all the elements are 0. Then we can call a zero matrix or null matrix. Diagonal matrix. A square matrix in which every element except the principal diagonal element is 0. So here, what are the diagonal elements of a square matrix? The elements that form a main diagonal in a square matrix. So here, what are the main diagonals? Here the first element, okay. The first element of the first row and the last element of the last row can be connected by a straight line. Straight line diagonally. The element from each row comes in the diagonal straight path. So here these are the principal diagonal elements. Other elements are 0. So this is called diagonal matrix. Next is square matrix. Now what is the rule of the square matrix? all the elements of its leading diagonal are equal and other elements are 0. So what did you understand from here? This is, we know, okay, all the elements of the square matrix, it is a square, okay, 3 by 3. That's first step is clear. Now, all the elements of its leading diagonals are equal and other elements are 0. So, same only here. What are the diagonal elements here? 2 and second it's 2 and 2. So, all the numbers are leading diagonals are equal. So, here 2 is now number 2 is coming, okay, 2, 2, 2. So, instead of 2 we can take any number, okay, 5, 5, 5. So, it should be equal and other elements are 0, then we can say square matrix. Okay. Next is unit matrix. So from unit only we know that the number is 1. So a diagonal matrix of order n which has unity for all its diagonal elements. Example, the diagonal numbers has come 1. Okay. So what is here diagonal numbers here? This is the diagonal shape. So it has come, all the diagonal elements are 1, 1, 1. If you are taking, this is 3 by 3 matrix. If we are taking 2 by 2 matrix, then here it will come 1, 0. How it is coming? 2 by 2 matrix. So example, this is a matrix. If I am writing 1, 0, then again 0, 1. Okay, this is what is the element. Okay, here 2 by 2 matrix. Clear? So 2 by 2 matrix. So this is we called as unit matrix. So now what is unit matrix? The diagonal matrix of order n which has unity. Unity means 1 should come for all its diagonal elements. Okay. So here what is the diagonal here? This is the diagonal. Next is transpose of matrix. So what is transpose? Okay, transferring something, is it? So the matrix got from any given matrix A by interchanging its rows and columns is called transpose of a matrix. Here the denoted by transpose, that means A transpose or A dash. Welcome. So now let us discuss with an example. So here, so we know that look-wise this is a square matrix. This is 3 by 3 matrix. Next is transpose matrix means, suppose here, what is that? Any given matrix A. For example, you take it, this is A matrix. Okay. So this is A matrix. Okay, we will take this is A matrix. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are transferring here. What we are transferring? So see here, we need here to interchange, okay, rows and columns. What we have to do here? Interchanging rows and columns, okay. So here, now we are going to interchanging, this is the rows. So what is the rows here? Numbers 1, 2, 3, okay. These rows we are interchanging the first row, okay, this is the first row becomes the first column. So just we will take the example here, see the blue color, whatever this is, we called as first row, okay, 1, 2, 3, it is interchanging. So what is that? First column, okay. Now what is here? Second row. Second row is 4, 5, 6. This second row it is interchanging second column. So 4, 5, 6. Clear now? So first row, first column, second row, second column, and third row, third column. Clear now? Okay. Now that means I can say here first row, first column, second row, second column, third one, third column. Let us take one more example here. Transpose of the square matrix. Here small 2 by 2 matrix. So here why it is 2 by 2 matrix? 2 rows, 2 columns. Is it? So 1, 2. So this is the first row. It is interchanging first columns. Next is second row. It is become a second column. Clear now? If it is, suppose we are taking the transpose of the rectangular matrix. So this is the rectangular shape. Okay. So here we can say that here 2 by 3. So first row here 1, 2, 3. It will come. It has become a first column 1, 2, 3, and 4, 5, 6. It has come second column. Next is, what is symmetric matrix? A symmetric matrix is a square matrix that is equal to transpose of its. Okay. So then it is satisfied, we can say that A equal to A transpose. So just now we discussed what is transpose matrix. Okay. So we are interchanging row and column. So first is same here, but it should be the what it is. It should be the symmetric matrix. Okay. Then what is the meaning of A equal to A transpose? What are the elements are here? It should come same number. Okay, that is we call the symmetric matrix. So here A equal to, what is the numbers element is here? 1, 2, 4. Okay, so we can interchange. That means we just now we learn about the transpose. So we are going to doing first transpose. Okay. So 1, 2, 4. First column it's come first row it's become first column. Okay. Next is 2, 6, 3, again 2, 6, 4. Now 4, 5, 4, 3, 8, here the column 4, 3, 8. Now you have to see that. Okay, what it is there? A equal to A transpose. What did you understand from this here? Here, see read the number 1, 2, 4. Here also 1, 2, 4. 2, 6, 3. Here also 2, 6, 3. 4, 3, 8. 4, 3, 8. Even this also 3 by 3 matrix, 3 by 3 matrix. So that means our condition is satisfied here. A equal to A transpose. What are the elements we are getting? That same numbers we will get A transpose. So that we call the symmetric matrix. Now, skew symmetric matrix. Skew means it will come minus. Okay. So here a skew symmetric matrix is a square matrix whose transpose equal to its negative. Okay. So here, so almost what we have to do the first step? First we should know that A. Okay, what are the element? Okay, what is the matrix here? Next, second step is we have to convert it into transpose. Okay, what we have done in the symmetry. So now the symmetry we know that. Okay, the here same element has come. Okay, A and A transpose. But in this case here we have to first row, first column. Is it transposing now? 0, 3, 2. Here 0, 3, 2. Now minus 3, 0, 5. It's come to column wise. Minus 3, 0, 5. Minus 2, minus 5, 0. Here minus 2, minus 5, 0. Okay, just interchanging. This is the third row and we have written third column. Okay. Now what we have to do that what is our condition here? Skewed symmetry is A equal to minus A transpose. If A equal to A transpose means we can say that it is a symmetric matrix. But in this case it is minus has come. Okay. So minus, what we have to do here now? Minus A transpose. That means we have to each element with the minus. Okay. We have to do it. So here 0 means 0. So we have no need to add minus. Now minus 3 become plus 3. Minus 2 plus 2. 3 plus 3. Okay, that is the no numbers. So means no sign here. It is means plus 3. So when we are adding minus here, minus 3, 0, minus 5. So here how it is coming the plus 5? That means minus 5. Then when we are, what is that, multiplying here minus 5, then it is become a 5. Now plus 2, minus 2 and 5. Okay, minus, sorry, here minus number will come because our question is given A transpose. Okay, here A transpose means 2 minus 2. Okay, minus 2, minus 5, 0. Minus 2, minus 5, 0. And minus 3, 0, 5. Minus 3, 0, 5. That means it is coming here plus 5. So here, now here minus we are adding here. So we will get plus 5 means it's come minus 5, then 0. Then note that all the diagonal element of a skew symmetric matrix are 0. So here what did you understand here? See here, this is our diagonal. Okay, this is our diagonal elements. So what are the diagonal elements of a skew symmetric A0? Some question may be the identification it will come. It is the whether it is skew symmetry or symmetric matrix. So from the diagonal elements are 0, okay, then you can say that this is the skew symmetric matrix. Hope you understood. Thanks for watching.